Hi everyone, in this video I'll show you the special right triangles. There are two triangles that come up over and over again in geometry, trigonometry, and other math subjects, and knowing the side length ratios will help you solve tons and tons of math questions. So first let's talk about the 30, 60, 90, outlined here in the darker color. Think about this. If you had an equilateral triangle to start with, like this outer triangle here, where we've got the pencil lines over here. An equilateral triangle, all the sides are the same length, all the angles are 60 degrees. So this angle would be 60, so would this one over here, and the entire angle up here. And the side lengths are all the same. So let's say the side lengths are 2x. And then let's say we construct this line here, this perpendicular bisector. Well, that does some interesting stuff. It gives us a right angle here. It bisects this 60-degree angle up here, giving us 30 here. And it bisects this base, meaning this side is x. So now we have a right triangle with a short leg of x, a hypotenuse of 2x, and this side, the long leg, is not known to us yet. Let's call it h. Well, we can figure out h in terms of x by using the Pythagorean theorem. So let's do that. X squared plus h squared equals the hypotenuse squared. So we got to remember to put the 2x in parentheses. So x squared plus h squared equals quantity 2x squared. Simplifying, we get x squared plus h squared equals 4x squared. That's just squaring everything there. Now we can subtract an x squared from both sides, giving us h squared equals 3x squared. And then we can take the square root of both sides, giving us h on this side. And on this side, well, x squared is a perfect square, so it can come out of there. And the root 3, that stays like that. So for this long leg, we actually can replace the h with x root 3. So for your 30, 60, 90 triangle, you've got these ratios. X for the short leg, x root 3 for the long leg, and 2x for the hypotenuse. A lot of my students like to remember it as just x, 2x, x root 3. So you're kind of thinking, you know, 1, 2, 3. X, 2x, x root 3. Just remember it's root 3 over here. So x, 2x, x root 3. Over here, the 45, 45, 90. So if you are given that it's a right triangle and that the angles are 45 degrees, you know it's isosceles. You may also hear this referred to as an isosceles right triangle. But either way, you know it's going to be the situation. The legs are congruent. These angles here are congruent. Let's call the legs length x, and the hypotenuse we'll call c. But we can figure out c in terms of x, again, using the Pythagorean theorem. So x squared plus x squared equals c squared. Well, let's write that, just flip that around and call it c squared equals x squared plus x squared. C squared equals 2x squared. Take the square root of both sides, and we get c equals, now again the x comes out of there, so it's x root 2. X root 2 for the hypotenuse of an isosceles right triangle whose legs are length x. So x, x, x root 2 for your 45, 45, 90. And x, 2x, x root 3 for your 30, 60, 90. And these are worth memorizing, these side length ratios, but it's also helpful to know where this comes from. So if you ever are stuck in a situation and you can't remember what these ratios are, be confident you can figure this out because now you know where this comes from.